Okay, this is 10.8. We're doing inverse trig functions. Okay, remember this is not reciprocal. All right, what comes after a million, billion, and trillion? Why? Quadrillion, quintillion, sextillion, septillion, octillion, and nonillion, of course. All right, today we're looking at inverse trig functions. The basic sine function fails the horizontal line test as a function, right? So when we look at these, we want to know if the horizontal line test is for the inverse. So since it does not pass the horizontal line test, it intersects in all of these places, then its inverse is not a function. So in order to make it be a function, we restrict the range. So let's look at what that looks like. Unfortunately, you don't get to see the animation on this slide, but basically what it does is it shows you that this graph, when rotated, turns into, I'm going to change color because I'm writing black on black. That's silly. Turns into this function. So our inverse functions look like this to get... Sorry about that. I'm working with Malachi at this point as well, so I had to pause. All right, so our new graph is actually a vertical thing all chopped into a little teeny piece. End up with not being able to have a function. See, when we rotate this across that x equal y line, remember that we rotated across an x equal y line, and what we would end up with would be something doing this, and so that's not a function. So what we do then is we chop it off at negative 45 to 45. No, it's not that. It's 90. It's negative 90 to 90. Wow. Okay. So that's what our new range is. Our domain is still the negative 1 to 1. Before that was range. When we do an inverse, it becomes the domain. But the domain used to be all real, but we have to restrict it so that now the range, instead of all real, is minus 90 to 90. In order that we don't... Okay, so the inverse sine function can be written in one of two ways. We've seen it as sine to the minus 1, not reciprocal. And we've also seen it as arcsine. Either way is fine, and they mean the exact same thing. Okay. The inverse sine gives us an angle or arc length. That's why you use arcsine within the unit circle. So this is giving you the angle as an answer. Remember, for a sine function, you put in a angle and you get out a ratio. The sine of 30 is opposite over hypotenuse. Whereas we do the inverse sine and we put the ratio in that. So we say the inverse sine of opposite over hypotenuse is a degree value of an angle. Okay, so inverse sine is either sine to the minus 1 or arcsine. The sine function gives us ratios representing the opposite over the hypotenuse in any of the four quadrants. The inverse sine gives us the angle or arc length on occasion on the unit circle that has the given ratio. When graphing on your calculator, use the domain and range to set the window to. Domain is negative 1 to 1, so your x-min is negative 1 and your x-max is 1. And your range is negative pi over 2 to a y-max of pi over 2. All right, remember the phrase arcsine is the angle or arc whose sine is x. So y is equal to the arcsine of x if and only if x is equal to sine y. Y is the arcsine or inverse cosine if and only of x, if and only if x is the cosine of y, etc., etc. Much of the work with inverse trig functions can be done by exact calculation rather than by calculator approximation. When you're asked to give an exact value, you cannot use your calculator. This helps increase understanding of inverse functions. If possible, find the exact value of the arcsine of minus 1/2. Well, it's already got it filled in for you, but we need to find the angle in the range. Remember, our range for arcsine are these two quadrants. Okay? So, the arcsine is negative 1/2, which immediately means it's down here. Okay? If it was positive, it'd be above the x-axis. Negative is going to be below. Actually, I should change my color, shouldn't I? So it's not so purple on purple. That's where my angle should be. We need to find the angle in the range such that the inverse sine of y is negative 1/2. Well, we know what angle has a sine of 1/2. We know that that's pi over 6. All right, so in this quadrant, the sine, which is associated with a y value, is negative. So in quadrant 4, it's negative. So therefore, my answer would be negative pi over 6. All right, to find the inverse sine of root 3 over 2, we need to find the angle in the range from negative pi to pi over 2, whose sine is positive root 3 over 2. Well, since it's positive, we know it's going to be in this quadrant. What angle has a sine of root 3 over 2? Hopefully we know that it's pi over 3. If you look up at the top of the slide where I have a triangle drawn out for you. For sine, it's opposite over hypotenuse. So opposite of the root 3 is this angle, which is the larger. Therefore, it's the pi over 3. This one would have been pi over 6. But it's pi over 3 because it's opposite the root 3. All right. What quadrant would it be positive and within the range of arcsine? First quadrant. Therefore, the answer would be pi over 3. Now for C, inverse sine of 2, there you can't have a sine of greater than 1, right? Remember our graph. Our graph was varying between 1 and negative 1. It would never have been up here. It would never reach 2. Therefore, we have no solution. All right, the graph of inverse trig functions. We have arcsine, arc cosine, and arc tan. The basic idea of the arc functions is the same as the inverse. And again, we've had to restrict things so that we don't have repeats. Okay, so these are now. Now, notice the one exception is that the domain for arc tan is infinity because it's this angle here and it there, and it just keeps going back and forth like this. No, it doesn't. I apologize. My bad. What it does is it just, like the arctan did, right? That kind of a shape. It's just rotated. Okay. Now, this is a visual that will help you remember what type of answers you get out of an arcsine or inverse sine, inverse cosine, or inverse tan. The arcsine or arctan both have the same two answer quadrants. They both will give you answers, sorry about that, in quadrant 1 and quadrant 4. All right, for arc cosine, See, the thing you have to remember is for arcsine, I have a positive here and a negative here. Well, that's true for tan also. Oops. But cosine is positive here and it's positive here because it follows the x. That's why we can't use the same two quadrants. That's why we bring over and use this one where arc cosine is negative. We have to be able to give you an angle based on a negative cosine. The only way to do that is to use these two quadrants instead. So you just have to remember that arc cosine, again, it's an x value. It's always weird. The x's always do weird things. Okay. If possible, find the exact value of the arc cosine of root 2 over 2. Well, I know that root 2 over 2 is a pi over 4 angle. All right, so it's pi over 4. It's in the first quadrant because it's positive, root 2 over 2. So my answer would be a positive pi over 4. Inverse cosine of negative 1 is pi. Well, the best way I can think of to remember this is the inverse cosine of negative 1. Well, where is x negative 1 on the unit circle? Right here. This gives you a pi, or 180, angle. So the inverse cosine of negative 1 is pi. All right, this is what you would do with your calculator. If you plug these in, 0.28, inverse cosine. Remember, you're going to be typing into your calculator inverse cosine, inverse tangent. And these are the values you'd get. Straight up in your calculator. You have to make sure you're in radian mode or degree mode depending on what answer you want. If you want an answer in degrees, you're going to have to be in degree mode. If you want an answer in radians, you're going to have to be in radian mode. All right. Use an inverse trig function to write theta as a function of x. All right, so what we do is we set this up, right? We know that, well, I've got adjacent and I've got hypotenuse. So I know it's going to be cosine. So I know that the cosine of theta is x over 4. No, 4 over x, apologies. Adjacent over hypotenuse. All right. Now, I need this to be a function of x. So what I'm... Oh, sorry, theta as a... So I have to have what this... Sorry. To write theta as a function of x, this means I need to have a theta equals. To get the theta outside the cosine, I take the inverse cosine of both sides. You see, that's what I'm doing right here. What that does is strip off the cosine, leaving me with theta, and then it's the inverse cosine of 4 over x. Now I have to state that x cannot be 0 because that would give me an undefined. Cosine is never undefined. Tangent is okay to be undefined. Cosine isn't, nor is sine. All right, for the second one, tan theta. Oh, I see. I'm sorry. I missed. You start with this thing. We can do it correctly here. I'm telling you that the tan of theta is x plus 1 over 10. Well, I draw a triangle. I choose an angle to be theta. There's my theta. And then I use these values, x plus 1 over 10. I know it's opposite over adjacent. So I label my triangle I've created opposite and adjacent. Now it wants what theta is. So I can say that the tan of theta, all right, so now I have, well, I know that tan theta is equal to x plus 1 over 10. Take the inverse tan of both sides. That takes away the theta. And now I have inverse tan of x plus 1 over 10. All right. Hopefully now you understand how to do that. Find the exact value, sketch a triangle. Okay, find the exact value and sketch a triangle. The cosine of the inverse tangent of 2. Well, the inverse tangent tells me that tan theta is 2. That's what that means. So if the tan of theta is 2, I draw myself a triangle. I choose a side theta, and then I label it opposite over adjacent, 2 over 1, so that it's 2. All right, now I use my Pythagorean theorem to define the other side. And that's where I got the root 5, right? Because it would be that's my c. So c squared equals 2 squared plus 1 squared, which is 5. So c is root 5. Okay, that particular c is nasty looking. Let me write it better. Okay, so I know c is square root of 5. That's how I got that number. All right, so now what's the cosine of my chosen angle? Remember, this is my chosen angle. Cosine is adjacent over hypotenuse. So it's going to be 1 over root 5, which rationalizes to root 5 over 5. All right, so that's my answer. Write an algebraic expression that is equivalent to this. Okay, so we know that the tan is 1 over x. That's opposite. So I draw my triangle. I choose my angle, theta, and now I label my triangle opposite over adjacent. All right, now I use my Pythagorean theorem to find that other side. Well, I know that that's x squared plus 1 squared equals c squared. To get rid of the square on c, I square root the whole thing. And 1 squared is 1. So this means that x squared plus 1 is equal to c. So that's where I got that hypotenuse. All right. Now it wants the cosine. There we go. It wants the cosine of that angle. Arctan gave me the angle. Now I want the cosine of it. So what I want is the cosine of this angle. Well, that's adjacent over hypotenuse. And there we go, adjacent over hypotenuse. And that's what the cosine of theta is. All right, find the exact value of the arc cosine of negative root 3 over 2. Answer in radians. Okay, so find the exact. That means I can't put it in a calculator. All right, so I know, what do I know? Okay, it's root 3 over 2 triangle. So I'm going to draw my triangle. And I know that the short side is 1, 2, and root 3. So the cosine is adjacent. So what's adjacent to the root 3? Because this is adjacent over hypotenuse. SOHCAHTOA. So adjacent is root 3. Hypotenuse is 2. So this angle, that's my adjacent. That's the angle I'm looking for. Notice it's opposite the 1, the smallest side. Therefore, this would be it's opposite the 1. Therefore, this is a 30 degree, which is pi over 6 in radians. So my answer would be, oops, we're not done yet because it's negative root 3 over 2, not just root 3 over 2. Now remember, our cosine answers are in these two quadrants. Since it's negative, it's going to be in this quadrant, which means its reference angle is pi over 6. That means that this angle, since this is pi, or 6 pi over 6, is going to be 5 pi over 6. So that's my answer. Okay, now, as long as you're positive, as long as what's inside the sign is in the first quadrant. This is not 3 pi over 2. So I can't just cross those two out. 3 pi over 2 is actually greater than pi. It's down here. That's 3 pi over 2. Okay. So the sine of 3 pi over 2, right? This point is 0 in the x, negative 1 in the y. So the sine is negative 1. So now what I have is the inverse sine of negative 1. Well, again, I'm only getting answers in these two quadrants. Everybody remember that. Okay, so negative 1 is down here. So the answer is actually negative pi over 2 because it's down there. So that would be my answer. All right, find the exact value of the tangent. So what am I going to do? I'm going to draw a triangle. I tend to always draw my triangles like this. I get comfortable with it. You can choose however you want to, but do it so you're comfortable. Okay, so cosine is opposite. No, it isn't. It's adjacent. Apologies. So ka. So it's adjacent over hypotenuse. So adjacent is 3 and the hypotenuse is 5. Well, this looks like it's going to be a Pythagorean triple, so we would have to check that. But this side should be 4. So what we have is 25, 5 squared, equals 3 squared plus our other angle. If I subtract 9 from 25, I get 16 equals b squared. So this tells me that b is equal to 4. So I was right. It's a 3, 4, 5 triangle. All right, now I know that. So I know what I'm really saying is the tangent of this angle. If I label that angle theta, what I really now have is the tan of theta. Well, that's not too hard. Opposite over adjacent. Opposite over adjacent. There we go. The trick is drawing yourself a triangle, using your Pythagorean to find all the sides, that kind of thing. That's the trick with all of these inverse cosines and stuff. All right, this is important to know. First, inverse trig functions are equal to arc trig functions. Anytime you see arc sine, it's inverse sine, same thing. Now, we also know that inverse trig functions are not ever equal to reciprocal. So arc sine to the minus 1 is not 1 over sine. There are no calculator keys for secant inverse or inverse cosecant or inverse cotan. So since this is not, since this is true, this is not equal to this, what you have to do instead is cosecant is associated with sine, but it's not 1 over the sine, it's the reciprocal of what's inside. It's the reciprocal of the value. It's not reciprocal of the function. All right? So this is true with all of these. If you have to find the inverse cotan of something, and you need to plug it in your calculator, you're going to have to find the inverse tan of 1 over whatever that value is that was in your cotan. All right. And we are done. Okay, we have review day tomorrow, and then the day after that is study guide, and then we have the test. So, be on your toes.